Hi all, in this video I am going to explain about relational algebra in DBMS. So we all know the importance of database nowadays. Everywhere we are using database and most of the organizations are dealing their data with database. So database is a collection of organized data. And nowadays we are using certain software for managing the data in the database. So these application softwares are known as database management systems. So in this video, I am going to explain the various operations which we are doing in a database. In a database systems, the data are stored in tables. Normally, a table contains rows and columns. So whatever data we are storing in a database, that is in the form of tables. Or we can say that in every database systems, the data is stored in tables. So once the data is stored in the tables, whenever the user requests the data, we can directly retrieve the data from the table. So, and also we have to perform certain database operations. That is, sometimes we have to add data into the database, or sometimes we have to change certain data in the database, or sometimes we have to retrieve. The most important thing is selecting or retrieving data from the database. So that is also possible for that purpose, or we can say that for doing all these database operations, we are using certain language. The most common language which we are using for performing these kinds of database operation is SQL. SQL stands for Structured Query Language. So before we are learning this SQL, we have to get an idea about the fundamentals of relational system and also the relational operations or the various operations performed in this relational system. So relational algebra provides the basic operations which can be performed over a single or multiple relations in order to generate new relations. So here we can say that the relation can be considered as a table. As I mentioned earlier, that is in database systems, the data is stored in tables. So whatever data we have stored, we have to retrieve the data. Sometimes we have to take or retrieve the data based on certain conditions, or sometimes we can retrieve all the data from the database or from the table. So that actually depends on the user requirements. We have to do all these kinds of operations. So relational algebra is a procedural query language which follows a particular syntax, and with that syntax we can access all the data which is stored in the database. So in relational algebra, it takes a relation, that is the table as the input, and also it processes, and finally it gives the output as a relation, or we can say that in the form of a table. So it provides a theoretical foundation for the relational databases and SQL. So if you have a clear idea about this relational algebra, then it will be better to understand more about the structured query language. Now I will explain the various operations or the various operators which we are used in the relational algebra. The various operators used in relational algebra includes the select operator, project operator, rename, union, set difference, and Cartesian product. So these are the various operators associated with relational algebra. First, we will explain about select operator, that is the select operation. So select operation is used to fetch rows from a given table or relation on the basis of given conditions. That is, based on a condition, we have to retrieve or we have to take the data from the database. That operation is known as select operation. That means selecting the data which we are stored in the database based on a condition. So in relational algebra, the select operator is denoted by sigma symbol. So the syntax is the sigma condition relation name. So sigma indicates the select operator, and the condition, whatever conditions we have to add, that we can include, and relation name is the table name. For example, if we are considering the relation student details having the attributes roll number, name, age and marks. And if you want to retrieve the data such as the name and also the student's age having greater than 21. So we can write like this: sigma, name and age greater than 21, student details. That is, sigma represents the select operator and name and age greater than 21. It represents the condition, that is, the details from the student data having name and also having the age greater than 21 will be retrieved. And student details represents the relation, that is the table name. So here this is the student details. Here we have some data, and if you are applying this select operation based on the condition, that is name and also the age having greater than 21, it will retrieve only the name and the age of the students having greater than 21. So based on a condition, we have to retrieve data from the database. We are using the select operation. Project operator. So project operator is used to fetch all the rows or tuples or data according to the requested attributes. That is, if you have to retrieve all the data, suppose we have a database. In that database, we have a table having 1000 records, and if you want to retrieve all the 1000 records, all the 1000 data, then we can use the project operation. So in that situation, we can either retrieve all the attributes values, or we can specify a certain attribute. So in relational algebra, the project operator is represented by the symbol pi, and the syntax is pi attributes and the relation name. Pi represents the project operator, attributes or whatever attribute we want to add, then we can add that attribute's name, and then relation name represents the name of the relation or the table. For example, if you are taking the student details having the attributes roll number, name, age and marks, and if you want to project the marks column, then we can write like this: pi marks student details. So it will retrieve all the students' marks in a arranged manner. So take this example. So this is the student details, and if you are applying this condition, that is pi marks and student details, then we will get the results. It will display all the marks of the students. So in this example, we have 3 records. So 3 records marks will be displayed as the output. Rename operation. The rename operation is used to rename a relation. That is, we cannot retrieve data from the database using this rename operator, but we can rename, we can give a new name to the relation. And in this relational algebra, it is represented by the Greek letter rho. And it is, the syntax is row, new name, relation name. That is, if you want to add, if you want to change the table name or the relation name, we can use the rename operator. Next is the union operator. As of now, we explained how to retrieve data from the database. That is, based on a condition we can retrieve data, or we can retrieve all the data which we have stored in the database. But in some situations, we have to take data from 2 relations and we have to generate a new relation. For that purpose, we are using this union operation or union operator. In order to fetch the data from 2 relations to generate new relation with combined capabilities, union operations can be used. And the union operation fetches the data from both tables and projects it accordingly. So it takes the data from both relations and it produces the result. And in relational algebra, the union operation is represented by the symbol U. And the syntax is x1, u, x2. That means x1 and x2 are relations and union represents the union operation. It combines both the relations and takes the required result. Here, consider the example or consider the relations x1 and x2. Both x1 and x2 have the same attributes, name and age. So if you want to perform a union operation, the one thing we have to ensure is that both the relations have the same attributes. So here, if you are taking this example, x1 and x2 are the relations and both the relations have the same attributes, name and age. So if you are performing the union operation, it will combine these 2 relations and it will produce the output like this. That is, it takes both the data from first relation and the second relation and combines it and it produces the result. Set difference operation. Set difference operation is used to fetch the data which is not present in any one of the relations. Suppose we have two relations and we have to retrieve data from the first relation which is available in the first relation and which are not available in the second relation. So at that situations we are using the set difference operation and it is denoted by the symbol minus. Here we can write like this, x1 minus x2 or x2 minus x1. x1 minus x2 indicates that the data which is present in x1 and which are not present in x2 will be retrieved. And in x2 minus x1, it means that the data which is present in x2 and which is not present in x1. So there are certain situations are coming. For retrieving data like this, we can use the set difference operation. Here is an example. Here we are taking two relations x1 and x2 and both these relations having the attributes name and age. So here we are performing x1 minus x2. So in this example it is clearly understood that the data which is present in x1 and which are not present in x2 will be retrieved. So in this table only one item is there, that is British, and his age is 90. So that data will be retrieved. And the second is the x2 minus x1. x2 minus x1 means the data which is present in x2 and which are not present in x1. So here we have two data, Anurag and Ganesh. So that data will be retrieved. So in this situation, so retrieving data like this, we are using the set difference operation. Next operator is the Cartesian product. The Cartesian product operation will generate the possible combinations among the tuples from the relations resulting in a table containing all the data. That is, in some situations, we have to combine the results from two or more relations to produce a single relation. That is, it combines the information of two or more relations in one single relation. At that situation, we are using the Cartesian product. So it checks all the possible conditions and it produces the required result. In relational algebra, the Cartesian product is represented by the symbol cross or X. So it combines two or more relations and produces the required result. So if we need to combine two or more relations to generate a single relation, we are using the Cartesian product operation. So these are the various operations used in relational algebra. So in this video, I explained about relational algebra and why we are learning about this relational algebra and the various operations and the various operators associated with this relational algebra. Thank you.